Hello, I welcome you all in this presentation related with the subject materials processing fundamentals and practical. And we are talking about the metal casting, and in the metal casting in this presentation I will be talking about the sand molding. Okay, the kind of the molding sand characteristics and the various factors that are important for the development of the sand mold, so that the sound casting of the desired size and shape can be produced. So, as far as content is concerned, in this one we will be talking about the molding sand and the characteristics associated with the molding sand. Okay, and then I will also be talking about the two important things like use of chaplets and chills in the sand mold. Okay, so primary role of these two in the sand mold is to help in development of the sound casting. Okay, chaplets are primarily used for supporting the core. Okay, so cores help in creating the internal features. So these are made using the core sand. Okay, and these are installed and fitted inside the mold with the help of the chaplets to support them. Okay, so these are made of the metallic pieces. Okay, so these also help to some extent in developing the suitable temperature gradient within the mold for developing the sound casting. On the other hand, if we see, these are the metallic pieces of the high thermal conductivity, so that and high you can say heat capacity, so that they can absorb lot of heat from the molten metal. Idea behind the use of chills, these can be used in the mold or near the mold wall. Okay, near the mold wall. So these chills, as the name appears, that these help to dissipate the heat rapidly, dissipate heat rapidly from the mold. Okay. So when this heat dissipation is facilitated with the help of the chills, this help in developing the suitable temperature gradient to realize the directional solidification and develop the sound casting. So basically the chills help in developing the directional solidification by controlling the desired solidification temperature, desired temperature gradient. Okay, suitable temperature gradient, while these chaplets support the core as well as also help in developing the suitable temperature gradient. Okay. So, we will talk about these aspects in detail. Additionally, we will also be trying to see the different parts and the components associated with the gating system. Okay, and what is expected from the gating system. So, can say the roles of gating system which is performed. So, the gating system is expected to do certain things which helps in development of the sound casting and realize high productivity. Okay. So, about those also we will be talking here. As far as the mold is concerned, in the gating system, if we see, the gating system has pouring basin, then sprue, then runner, then ingate and mold. Okay. And after the mold we have riser. So, these are the different components. The mold is one part of the gating system, but this is one which will be determining the size, shape and soundness of the casting produced. Okay. So, it is very important that the mold is prepared and prepared properly using the molding sand of the desired characteristics. Okay. So, that the sound casting can be produced. Okay. So, how good and how sound casting will be produced, that will depend upon how good mold cavity has been produced apart from other parts of the gating system. So, main idea behind making proper sand mold is to produce the sound casting which is free from any kind of the porosity, inclusions, or kind of the shape which is desired and the size. Okay, so the desired size and shape, and in addition to this, even if there is any tendency for having the impurities, inclusions, or such kind of the defects, then those tendencies are minimized with the help of directional solidification. So here what we tend to see that the solidification start at one end at one location, and that ends at another location, and it proceeds in one direction. So, whatever impurities that we have, if any, in the molten metal, they will be segregating at the top. So, therefrom these can be removed easily, and that is how it helps in reducing the porosity and inclusions, and this can be done by designing the gating system properly, so that the suitable directional solidification is realized by developing the desired temperature gradient within the mold. Okay. So, these are like the main requirements of the mold, so that we can get the sound casting, we realize the desired directional solidification, and the casting is made of the desired size and shape. As far as the gating system is concerned, this is the pouring basin where the molten metal is fed with the help of a ladle. From the ladle, the metal is received from the furnace, and it is transported with the help of ladle, and it is poured into the pouring basin. From the pouring basin, it flows through the sprue, and then in at the sprue, then there is the sprue base, which helps in determining the flow rate. This area can be termed as a choke. Okay, this from this the choke, from this sprue base, the metal, there is a change in direction of the flow of the molten metal, and then it flows through the runners. Okay, and then with runner transports the metal to the ingates. In ingates, the impurities are filtered out if there is any, and it feeds the molten metal to the mould. So, in this is say this entire zone is the mould where the molten metal will be filled in. Once the molten metal has been filled in the mould, the molten metal then will be filling to the riser. Okay. So, here this is how the flow will be happening, in the flow of the molten metal will be happening in the in the gating system. Now, depending upon the complexity of the shape of casting, okay, shape of the mold, we can use multiple runners and multiple ingates that will help in realizing the filling the molten metal fast, smoothly, okay, and as quick, and you can say starting the solidification as early as possible, almost at the same time in different zones, and filling all sections, okay, so that no unfilled section is left, and ensuring the proper mixing of the molten metal coming from the different sides, different ingates, so that the cold shut or misrun kind of the defects can be minimized. So, the point here is like the number of runners and number of ingates. These are designed in such a way that the cavity is filled in as short time as possible and smoothly. Okay. So, that, and also it helps in developing the suitable temperature gradient for developing the sound casting. Okay. And here each component is designed actually, so that we get, as per the metal systems, the sprue and the choke area, runner, ingates, the riser, everything is designed, means the size and shape of the every component of the gating system is designed to realize the desired productivity and sound casting. So, what are the main functions performed by the gating system in the casting? Like, to help in development of the suitable temperature gradient to realize the directional solidification, so that it starts at one end and progresses at other end. So, this helps in development of the sound casting, and if there is any defect and impurity, then that will be developed at the one end. So, therefrom it can be taken care of. Then to feed the molten metal into the mold in minimum possible time. Okay. And then also it should be as smooth as possible. So, to feed the molten metal for compensating the shrinkage. So, this role is performed by the riser. Okay. So, when the you see there is, say there is a mold. Okay. So, mold initially will be filled in, then temperature of the molten metal will be coming down. Okay. So, there when the temperature comes down, then there will be shrinkage, the one shrinkage due to reduction in temperature of the liquid metal. Okay. Then the another shrinkage will be happening due to the change of frame phase from the liquid to solid. So, these two types of the shrinkages must be taken care of by the gating system by feeding the extra molten metal desired to deal with these two shrinkages. One, shrinkage of the reduction in the volume of the molten metal due to the drop in temperature from one temperature to the solidest liquidus temperature, and thereafter the one then the shrinkage that will be happening due to the change of phase from the liquid to solid, and both types of these shrinkages must be taken care of by the gating system, and that role is performed by the riser. Okay. Riser feeds the molten metal, okay, to for compensating the shrinkages. Okay. And then to remove the impurities, like say despite of all care, sometimes like say sand particle or oxide which has been formed in course of the transport, these impurities should be removed in order to avoid the defects. So, these impurities must be taken care of wherever possible. So, the pouring basin is one that will helping in to remove these, then ingate is the another member that helps in removing these impurities like dross and the light floating impurities from the molten metal. So, the another important role which is performed by the gating system is to remove the impurities. Okay. Then to minimize the turbulence, it is very important, especially in case of the sand mold, that the molten metal is fed smoothly. Okay. If it is fed, if it is not fed smoothly or it is fed in turbulent manner, then what will happen? Lot of molten metal will be interacting with the atmospheric gases, will be increasing the tendency of the oxide formation or the defect formation or the chemical interaction of the molten metal with the atmospheric gases. Another, dissolution of these gases in the molten metal, that is the another problem. So, and the third possibility is that turbulent flowing the molten metal which is flowing in turbulent manner will tend to damage the mold walls or the different members in the gating system, those can also get damaged, and which in turn will be leading to the presence of the sand particles in the molten metal which is going into the mold. So, will be leading to the defects. Okay. So, it is very important that the molten metal is fed smoothly into the mold. Okay. So, to minimize the turbulence, you see the one of the major function of the gating system is to minimize the turbulence inflow of the molten metal, to reduce the excessive absorption of the gases or oxidation of the molten metal and erosion of the mold wall. Okay. So, erosion will change the size and shape of the mold and also of the other members of the gating system. Oxidation will cause the presence of the inclusions in the casting, and absorption of the gases in the molten metal will be leading to the porosity. Okay. So, in order to produce the sound casting, it is important that the turbulent flow of the molten metal is avoided, and this kind of the turbulence is minimized by ensuring the proper design of the gating system, so that the molten metal is filled in the mold smoothly. Okay, then now we will be talking about the like the mold. You see mold, as I have said, in a gating system is one member. Okay, but it is very important member, it is very important component because it determines the soundness of the casting apart from the size and shape. Other members of gating system helps in ensuring this aspect. Okay. This mold can be made of the sand. Okay. That in that case the sand is not just the sand, but it will have the other members, other components like clay, which is acts as a binder, water and other additives as per the requirement of the characteristics. So, a mixture of all these like the sand, clay, binder and water and additives, all the mixture of all these is known as molding sand. Okay. This molding sand is used for making the mold. Okay. And when the sand molds are used, these are used for one use only. Okay. After making the casting, the sand mold has to be broken. But so these are called expendable. So there is complete loss of the mold. So just for one use, this kind of the mold is used. So sand mold, the mold can be made of the sand that using the molding sand, but this is good for single use. But if you want a single use, means the volume of the production is less, means number of units to be produced is less, that is one, or the design is of the variety. You see multiple varieties of the design and the very frequent change in the design and the low volume. So, if that is the kind of case, apart from that certainly the economics will be playing its own role. Things should be economical at the end of the day for manufacturing component. Okay. So, sand mold can be used, molding sand can be used for making the sand mold. Then molds can also be made using the metals. Okay. So, these metals can be steel, it can be cast iron or it can be brass, depending upon the metal to be processed for casting. But most of these metals are high in density. So, these molds are heavy, okay, but these also offer higher thermal conductivity. These offers the very good finish surface finish which is of the mold wall is very good, and these allow very good close control over the tolerance. So, the tolerance control is very good. Okay. Surface finish is good, dimensional accuracy is good, but these offer higher thermal conductivity and these are heavy in weight. So, handling will be difficult of the metallic molds, but high thermal conductivity will offer the higher cooling rates to the molten metal during the solidification. So, these are the various features. Now, where and what for these are good? Since the making the metallic mold is a costly affair, okay, and these will be used for the multiple times use. And since it is costly to make the metallic dies for the casting, so these their use is justified when high volume production is needed. Okay. Number of units to be produced is very large, that is one, and there is a very rare or less tendency, okay, less tendency for design change. If that is the case, then our metallic molds are preferred. Okay. So, now there are multiple other variants like hot or cold chamber die casting, that is one. So, depending upon the way by which the hot metal is maintained, like if we continue to heat while it is in a store, then it is called hot chamber die casting. This is particularly used for the low melting point metals like the zinc, magnesium. On the other hand, cold chamber die casting, when no external heating is done. So, in that case this is used for the high temperature metals. There is no separate provision for heating the molten metal. So, hot chamber die casting allows the higher production rate as compared to that of the cold chamber and the die casting. But if you see the feature related with the high cooling rate being offered by the metallic molds due to the high thermal conductivity of metals as compared to that of the sand, high cooling rate allows the lesser, it takes lesser solidification time is less. So, if the solidification time is less, the high means the higher solidification rate, higher along lesser solidification time, or due to the higher cooling rate, what we get basically the high nucleation rate and the low growth rate. Okay. So, when high cooling rate is used, we get the benefit of high nucleation rate and the low growth rate. Okay. So, when the high we have the high cooling rate, it offering the benefit of high nucleation rate and the low growth rate, that in turn results in the large number of the nucleants, okay, during the solidification. So, that in turn offers the advantage of the fine grain structure. So, the thing is, when we use the metallic mold, we get the fine grain castings as compared to that of the, you see, as compared to that of the sand mold casting. Okay. This is primarily attributed to the difference in the cooling rate that is achieved due to the difference in the thermal conductivities associated with the two types of the molds. Okay. A ceramic mold is used in the investment casting, shell mold casting. Okay. So, in this case we use the ceramics for making the mold. Certainly due to the low thermal activity, these are usually thin walled, so these offer the low cooling rates. Now, as I have already said, the molds can be for single use or multiple uses. So, single use molds are basically sand mold, and also the ceramic molds used in investment casting and in your the shell mold casting. These are also single use. For multiple uses, we use the metallic mold or the die casting or metallic dies. Okay. The molds, as I have said, that depending upon the mold material, okay, mold material, we get a lot of difference in terms of the characteristics of the mold which is produced. So, mold material affects the quality of casting. Why? Because the kind of surface finish that is realized, that is affected, and the kind of the cooling rate that is offered, that heavily depends on the type of the mold material, and the cooling rate affects the grain structure, and in the grain structure in turn affects the mechanical properties. Okay. So, the mold material, therefore, what we say significantly affects the quality of casting, because it affects the surface finish and the tolerance that is realized, high cooling rate offering the finer grain structure and improved the better mechanical properties. Okay. So, this difference is attributed to the surface condition of the mold wall, the strength of the mold wall, because metals are certainly stronger than than our the molding sand molds, and the refractiveness is also high, and the cooling conditions and the heat dissipation that is offered by the metallic walls as compared to that of the sand mold, and therefore we get the reasonably good quality of the castings produced by the sand molding. Okay, for making the sand mold, we use molding sand. As I have said, molding sand is composed of the like green sand, okay, which is like the sand taken from the river. Then we have to add the clay, which acts as a binder. Then we use the water to activate the clay, and we can also use some additives to impart certain properties like the high refractoriness or the improved porosity. Mixture of all these is known as the molding sand. Okay. So, the molding sand, as I have said, the mixture of the four different components. Then now let us talk about the different types of the sands which are used. Okay. So, like let us say we are using the two flasks, one is the cope, that the top one, and another is drag. Okay. So, here the junction between the two is this, a part of the pattern will be there at the top and part of the pattern will be at the bottom, and here around the pattern the molding sand will be packed. Okay. So, you see what is done basically, the molding sand is packed all around. Okay, the molding sand is packed all around. Okay, but at the surface, at the surface where we want that the cop and drag will be separated. Okay, so here we use the parting sand at the junction, so that the two parts can be separated. And then the backing sand is, this is like the old sand which is being reused. Okay, so the backing sand is placed on the back side because it does not play not close to that of the pattern, but it is placed back side near the mold flasks wall. Okay, and then we will be having the molding sand which will be playing a major role. Then the surface next to the pattern, okay, is applied with the facing sand. Okay, so facing sand is one which is applied on the surface of the mold wall. Okay, this is done primarily to improve the refractiness. Okay, so that the high temperature stability of the mold surface is improved, and also to improve the surface finish. Okay, so each type of the sand performs the different role. Parting sand helps in easy separation. Backing sand is just provide the support. It is used as a filler. This is the reused sand, and which is conditioned, and then the facing sand is applied on the mold surface for improving the refractiveness and the good surface finish. And the molding sand is one which will be in vicinity of the pattern, which will be offering the desired characteristics to the mold for producing the sound casting. So, what are the characteristics that are desired for producing the sound casting? About that we will see. So, as far as the characteristics are concerned, these are the permeability. Okay, permeability is one. Okay, say this is the mold, and all around that we have the moldings, the mold wall. Okay, made of the molding sand. This mold wall is expected to perform certain roles, like it should take the weight of the molten metal, okay, without changing the shape and size. So, mold must be strong enough to take the weight of the molten metal without getting damaged in terms of the size and shape. Okay, like it may the mold walls may get pushed away under the metallostatic pressure, or these may get eroded, okay, if it is of the low strength. So, we will talk about the multiple aspects here. So, since the molten metal, say if it has been molten metal has been filled in here, so molten metal, if it is having the dissolved gases, then these gases must be allowed to escape. Okay, so the gases which are there in the molten metal should be allowed to escape, and this escaping is possible only through the pores which are there in the sand mold. Okay, so if there are enough pores, then they will allow the easy escaping of the gases dissolved in the molten metal. So, how easily the gases are able to escape, that depends on the permeability. Permeability depends upon the size of the sand, size range of the sand particles. Okay, then the kind of the moisture which has been added, and the binder, and then the kind of ramming which has been done. So, higher ramming, greater binder, greater moisture, wider size range, and finer size, all these reduce the permeability, means they will make the escaping of the gases difficult. If the gases are not allowed to escape from the mold wall, then these will be entrapped in the molten metal, and which in turn will be leading to the development of the porosity within the casting. So, it is very important that the it is important that the porosity of the mold is good. Okay, strength rule, I have already said, the mold must be strong enough to take the weight of the molten metal without getting modified in terms of the size and shape. Okay, and that again will depend upon all these factors I said, like the size and the kind of the moisture which has been used or the binder. Okay, and so these must offer the reasonably good strength actually, so that the shape of the mold can take the weight of the molten metal under the casting conditions, under the high temperature conditions imposed by the molten metal. So, depending upon the condition of the molten metal, depending upon the condition of the mold, like when the sand mold prepared by the molding sand is having the moisture, in that condition strength of the mold is known as green strength. Okay, if the mold is baked to remove the moisture. Okay, if the moisture is removed, then in that condition, when the all moisture has been driven off, then what we see, strength of the mold in that condition is known as dry strength. Okay, and the strength of the mold at high temperature of the molten metal, then it is known as hot strength. What matters most is the hot strength, because mold must survive the high temperature of the molten metal without getting damaged. Okay, in general, reducing the moisture, like during the baking moisture will be removed, so we get the higher dry strength. Okay, but what matters most is the hot strength of the mold. Okay, so if we try to see here, like say strength versus temperature versus the moisture, then for the green strength, no, green strength is less. Okay, and the temperature is also less and the moisture is high. Okay, on the other hand, if we talk of the hot strength, in that case our the temperature is very high and strength is also high, but moisture is minimum, temperature is high, strength is also high. So, the thing is that the temperature conditions significantly affect the strength, moisture related with the green sand mold. Okay. Now, like say the sand mold which has been made, okay, this is the mold wall. Okay, it is coming in contact with the molten metal. So, this will be exposed to the high temperature. If the mold wall surface is not refractory enough to sustain the high temperature of the molten metal, then it will get fused and mix with the molten metal. If the mold wall fuses and mixes with the molten metal, only the hard surface will be produced, which will be difficult to machine. It will modify the shape of the casting also. So, it is important that there is no melting of the mold surface. Therefore, it is important that whatever the molding sand has been used, it offers the desired refractoriness. Refractoriness although depends on the kind of the binder which is being used and the type of the sand and the sand size. Look, so large size sand particles offer the greater refractoriness, and the kind of the binder also affects the refractoriness of the molding sand. Collapsibility, you know, since the sand molds are made for one use, these are single use. Okay, so after solidification of casting, these need to be broken. Okay, but you see, these need to be broken, but what happens, like say there is a mold and the molten metal has solidified. Okay. So, this mold, after the solidification, the casting will be shrinking in the solid state, shrinkage in solid state. So, with the shrinkage in solid state is happening, then mold under the effect of the compressive stresses that will be developed due to the shrinkage, the mold should break. If it does not, then it will tend to develop the residual tensile stresses, and which will promote the hot tearing or cracking tendency or distortion tendency. Okay. So, it is important that during the solidification, when the cooling of the casting is taking place, the sand mold should break easily. Okay. Otherwise, this will increase the tendency of the defective casting. Okay. So, high collapsibility means easy breaking of the molding sand when the casting is being taken off. Okay. Flowability decides like how easily the molding sand is flowing during the molding process, so that it follows the shape of pattern to produce the desired shape of the mold cavity. You see, the flow of the molding sand must be good, so that it follows, okay, it follows the pattern surfaces, and this is especially important when the sections are thin and the geometry is complex. Okay. It is difficult to make sure that the molding sand flows and follows through the thin sections and especially of the complex geometries. Once if it flows, then we will be able to produce the desired features on the mold surface and to produce, and we will be able to produce the castings of the desired shape. Okay. Adhesive strength is about the bonding of the molding sand, okay, either with the pattern or with the flasks. Okay. When it bonds well, then it helps in taking the shape of the mold desired. If that bonding does not happen, then the desired shaping of the mold will not be happening, and that will make the molding process little difficult. So, as I said, molding sand is composed of the green sand, clay and water, and the strength of the mold in different conditions. The green strength of the mold is termed when there is a moisture with the mold, and when the moisture is driven off by baking. So, there is a no moisture. In that case, the strength of the mold is known as dry strength, and the strength of the mold under the condition of the temperature of the molten metal. Okay. So, the strength of the mold at a high temperature corresponding to the molten metal temperature conditions is known as hot strength. Okay. Now, as far as the chaplets is concerned, so the chaplets are metallic pieces that are used to support and position the cores within the mold, so that desired internal features can be maintained. Incorrect chaplet can cause the defects and the weak zone formation. So, it is important that it is of the desired size or section thickness, okay, so that it takes the desired load for providing the support to the core, as well as it offers the desired soundness. How these can be made of the similar composition as the casting metal, or these can be different, but it is desired that these are made of the similar one, because these will be forming the part of the casting basically. Okay. So, optimum size of the chaplet is very crucial. Chaplet must be large size enough to avoid the complete melting, and if the chaplet melts completely by the molten metal, then it will not be able to provide the support to the core, and it should be small enough so that the surface melts and fuses with the casting surface. So, this is just like this needs to be optimized. Okay. Say there is a kind of a core, okay, and here we need to provide the chaplet. So, this is core and this is chaplet. Okay. So, this chaplet size must be optimized, section thickness must be optimized. What we want, under the effect of heat, the surface of the chaplet melts, okay, and later on it becomes the part of the casting. So, this is possible only if it is thin enough. Okay. But if it is very thin, then what will happen, entire chaplet will melt, and that will can displace the core from its position. So, that is why the optimization of the size of the chaplet is crucial. Chaplet must be large enough to avoid the complete melting, or small enough so that the surface melts and fuses with the cast surface to become a part of the casting. Okay, the chills, as I have said, these are the metallic pieces of high heat capacity and high thermal conductivity. These are placed in the mold suitably. These can be placed within the mold or outside the mold adjacent to the mold surface. Okay. So, placed internally or externally adjacent to the casting mold surface or within the mold. Okay, these help in development of the suitable temperature gradient in the molten metal during the solidification to promote the directional solidification by accelerating the localized cooling. Okay. So, these acts as a localized heat sink, and that in turn helps in developing the suitable temperature gradient. And once this is done, it helps in increasing the effective feeding distance from the riser, and it also helps in reducing the number of risers required for casting. Now, I will summarize this presentation. In this presentation, I have talked about the importance of the designing and development of the mold properly, and the kind of characteristics that are needed in the molding sand, and what are the different functions performed by the gating system. Apart from that, I have also talked about the role of the chaplets and chills in the casting. Thank you for your attention.